Hello, welcome back to the channel. So let's do one more question on numerical integration, which is based on interpretation of graphs. So in this question, we have to interpret this graph, which is the graph of the fourth derivative of f of x, in order to calculate the value of L, and then based on that value of L, we'll have to estimate the maximum absolute error and also calculating the number of subintervals which will ensure our absolute error to be less than this value over here. So it is basically the same process that we followed in the last video. The only difference is in this question, instead of calculating the fourth derivative of f of x manually, we'll have to interpret this graph and find the upper bound on the absolute value of the fourth derivative of f of x using this graph over here. So now let's first calculate the value of capital L, which we will be able to interpret using this graph over here. So since we know that this is the graph of the fourth derivative of f of x, and for the calculation of the value of L, we are concerned with calculating an upper bound on the absolute value of fourth derivative of f of x. So we'll have to figure out what the extremas of this graph over here is, right? So there are two extremas over here, right? Based on the interval where x lies between 0 and 2. So based on this interval, we have one extrema over here which is at minus 310, and the second extrema over here is when this is equal to 90, right? And we know that since we are only concerned with the absolute value of the fourth derivative of f of x, we can clearly notice that this value would give us the value of capital L, and that value would indeed be the absolute value of minus 310, right? Because we want to calculate an upper bound for the absolute value of fourth derivative of f of x. So if we calculate the absolute value of this graph over here, we will get our maximum value to be 310 in this case, right? So based on this interpretation, we can easily see that our L is equal to 310, and now we have to estimate the maximum absolute error in using S8 to approximate I. So S8 is basically the Simpson's rule approximation when your subintervals are 8. So now you know the formula in order to calculate the maximum absolute error. You can basically plug in all those values into this formula. So we know that the maximum absolute error, which is also denoted by En, is less than equal to L times b minus a to the power 5 upon 180 n to the power 4. And now you know all the values. So L is 310, b is 2, a is 0 in this case, because the lower endpoint is 0, the upper endpoint is 2. And then you're using 8 subintervals, so it would be 180 times a to the power 4. And then if you'll calculate this expression over here, you'll get the maximum absolute error in using the Simpson's rule approximation with the number of subintervals to be 8. And now for the second part, you have to calculate how large should your n be, your number of subintervals be, in order to ensure that your absolute error is less than 0.0001 in this case, so 10 to the power minus 4. And now you know all the values in this expression except for the value of n which you will be calculating. So you want this error to be less than 10 to the power minus 4, right? And again, by using the same concepts that we covered in the last video, we'll solve another inequality. We'll basically equate this equation to be less than equal to 10 to the power negative 4, right? And then when we'll solve for this inequality over here, we will get the value of n. But there is also one important thing that we already covered in the previous video as well, that if you're approximating your definite integrals using Simpson's rule, you have to ensure that first of all your n is a whole number, and the second point, which is more important than the first one, is that your n should always be an even number when you're approximating using Simpson's rule. So since in this case we want our n to be a whole number which is even and also greater than 27.2, so the number which satisfies both of these properties, both of the properties that we discussed, would be n greater than equal to 28, right? So any even integer which is greater than 28 in this case would guarantee our absolute error to be less than equal to 10 to the power negative 4 in this case. So that's it for this video. Again, the main takeaway from this video is, even when you have these interpretation of graph questions, you have to follow the same approach in order to calculate the value of L, which would be the upper bound on the absolute value of the fourth derivative of f of x. So based on the graph of the fourth derivative of f of x, you can easily calculate the upper bound on the absolute value of the fourth derivative of f of x, like we already covered in this video over here, right? Since we identified in this case that the extremas were at 90 and minus 310, and we were only concerned with the absolute values, so our L came out to be 310 in this case, right? So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.